if I wanted to find the fourth root of 16, I would factor it down and I would get 2 times 2 times 2 times 2. And this number tells me I need groups of 4. I have one group of 2's, so I write a 2 on the outside and there's nothing left on the inside. So the answer is 2. If I wanted to put that in my calculator, I have to push the root first. So I push 4, and then math, and then number 5 says x root. And if you have the newer calculators, the 4 actually becomes the root. If you have the older calculators, then it will say 4x root. And it means the same thing. And then I could plug in 16, and I get 2. So you push the number 4. You put whatever number this is, you push that first, and then you find the x root button. And so your calculator may look like this. That's just the older type. Okay. So if you look at exercises 4.1, 5 through 10, it tells you the root number, and then the number that you're taking the root of. So number 5 says n is 3 and a is 8. That's just asking what is the third root of 8. And you either know it or you need to plug it in your calculator and you get 2. Okay? But there's another way to write third root. Do you know what it is? As an exponent. It's 1/3. So the third root of 8 is equivalent to 8 to the 1/3. Third. Okay? But what if I had 8 to the 2/3? Well, the bottom number is asking, can 8 be split into 3 equal multiplications? Can I do something times itself and equal 8? 2 times 2 times 2. Okay. And what does this number tell me? We're going to take 2 out of the 3 multiplications. So this would equal 4. So 8 to the 2/3 is equivalent to the third root of 8 squared, or 2 times 2. And that's where we're headed. Let me do a couple of these, and I think you'll get used to it. Okay, what about 3, let's do 32 to the 3/5. Can 32 be split into 5 equal multiplications? 2's, right? 2 times 2 times 2 times 2 times 2. So 32 is really just 2 to the 5th. And how many of those 2's belong to my answer? 3 of them, which gives me 8. Now, it could be written like this, or it could also be written as the 5th root of 32 to the 3rd. Eight is the answer. Yeah. So you could type this in your calculator, 32 raised to the 3/5, and you'll get 8. Or the 5th root of 32 to the 3rd, or you can break it up into 5 equal multiplications and then take 3 of them. Okay. What about this? Can 27 be split up into 3 equal multiplications? Yes, what would they be? 3 times 3 times 3. And the answer I'm looking for contains 4 of those 3's. So I need to put another one on there, and I get 81. Now, I don't think we're going that far today, but I think it's valuable for you to see that before we get there. So the other way would be the third root of 27 to the fourth. And the weird thing is, you can actually put the 4 on the outside or the inside, and it's not going to matter. So you could say the third root of 27 to the fourth, which is exactly the same thing. It doesn't matter whether that 4 goes outside or inside. And sometimes inside makes more sense and sometimes outside makes more sense, but we're not going to get into that today. So 5 through 10, all you're doing is taking the root. Can we take roots of negative numbers? So can I take the square root of a negative number? Yes, but there are some rules. What happens if you square root a negative? You get an I. For instance, the square root of negative 4 is equal to 2i. What if it's a third root? The third root of negative 8. Is there a number times itself that equals negative 8? Negative 2. Okay. What about the fourth root of negative 16? (2i). Okay. What about the fifth root of negative 32? That would be negative 2. So how come some of them give me an I and some of them give me a negative? Right. If you multiply a negative an even number of times, it goes away. If you multiply a negative an odd number of times, it sticks around. So any root that is even, 2, 4, 6, 8, will create an I when you root a negative. It will. Because there's no way to line up 4 negatives and create a negative. That's what the square root, the fourth root of negative 16 is asking. If you put 4 multiplications together, can you have a negative? No. Because the first 2 will cancel into a positive and the last 2 will cancel into a positive, and you're left with a positive. Okay? But if the root is odd, then the negative just becomes part of the answer. The negative comes out of the square root. No. The even ones turn into an I, the odd ones do not. So if this number is even, then you end up with I's. If this number is odd, then that negative just comes out and becomes part of the solution. You can. So you can just plug it in, and if it gives you an error, it'll probably say non-real answer. So if I tried to take the square root of negative 5, it's going to give me an error, non-real answers. Oh, just ignore the negative? Yeah. But on the other side, you can just type it in and it'll work. So if I wanted to do the third root of, say, 125, negative 125, that will actually give you the correct answer. So yeah, you can just ignore the negative and then apply the rules afterwards. That's totally fine. All right. So numbers 11 through 16 need to be converted into well, they need to be converted into radical form and then simplified. So if I had 81 raised to the 3/4, what would that be in radical form? It would be the fourth root of 81 to the third. Can 81 be split into 4 equal multiplications? Yes, 3s. So it's 3 times 3 times 3 times 3, And how many of those 3's are part of my answer? 3 of them. So the answer would be 27. Okay. What if I had 8 to the 5/3? In radical form, that would be the third root of 8 to the 5th. Can 8 be split into 3 equal multiplications? 2 times 2 times 2, and my answer contains 5 of them, times 2 times 2. That would be 32. What if this 8 was negative? Then that would be negative 32. Why? It's an odd root. If that was an even root, then it would be an I. Okay, we getting the hang of that? That takes care of the first 2 sections. Matched equivalent expressions, you got that. That's pointless. We'll skip that. Okay, so what if I had, say 5x to the 4th equals 625? How would you solve that? Divide by 5. We got to get rid of the coefficient first, and I get x to the 4th is equal to 125. Now what do? I take the 4th root of both sides, and the 4th root and the 4th power cancel, and I get x is equal to something. There's a rule that you need to apply before you type that in your calculator. Plus or minus. Do you remember that? And then for math, 5th root of 125. It's going to be 4th, yeah. So plus or minus 3.3. Why is this plus or minus? Because the root was even, right? Do you remember back when we did stuff like x squared equals 9? What 2 numbers work in that case? Plus or minus 3. So if plus or minus 3 works when we have x squared, then it's also going to work when we have x to the 4th, because it's an even number. Okay, so anytime you take the root, the even root of an x to an even number, you're going to end up with plus or minus every single time. Just like we did with x squareds, the same is true of x to the 4th and 6th. But the odds don't work that way. Let's say I had 8x to the 3rd equals 64. What do I do first? Divide by 8. X to the 3rd is equal to 8. I take the 3rd root, and I get x is equal to, is it plus or minus 2? No, just 2. The reason is 2 times 2 times 2 is 8. But if I make those negative, then it equals negative 8. But if I had x to the 4th equals 16, do I need a plus or minus? Yes, because negative 2 times negative 2 times negative 2 times negative 2 will end up with a positive. So what you need to remember is, if there is a negative inside an even root, it creates i's. Negatives inside odd roots don't. And then if you take an even root of a variable, you always need plus or minus if that root is even. If it's odd, you don't. Okay? So your assignment, 4.1, or is it 4? 4.1. And we'll start 5 through 18. Oh, those are really easy problems. Oh no, 5 through 24 all. Nope. Yeah, 24. And then 35 through 44 all. Okay, good luck.